Hello guys, I'm Satish, Mechatronics student of SNS College of Technology. I'm here to present you a technical presentation about electromagnetic clutch. A clutch is a machine for transmitting rotor which can be engaged and disengaged. Clutches are useful in devices that have two rotor shafts. In these devices, one shaft is typically driven by a motor or pulley, and another shaft drives another device. The clutch connects the two shafts so that they can either be locked together and spin at the same speed, or be discoupled and spin at a different speed. The clutch disc spins with a flywheel. To disengage, the lever is pulled, causing a white pressure plate to disengage the green clutch disc from the turning the device shaft, which turns within the thrust bearing of the lever. Never will all three rings connect with any gap. Electromagnetic clutch. Electromagnetic clutch operates electrically by a transmit torque mechanically. This is why they used to be referred to as a electromagnetic clutch. Let's see about the construction of the electromagnetic clutch. A horseshoe magnet has a north and south pole. If a piece of the carbon steel connects both poles, a magnetic circuit is created. In an electromagnetic clutch, the north and the south pole is created by coil shell and the wound coil. In a clutch, when power is applied, a magnetic field is created in the coil. This flux overcomes an air gap between the clutch rotor and the armature. This magnetic attraction pulls the armature in contact with the rotor face. The friction contact, which is being controlled by a strength of the magnetic field, which causes a rotor motions to start. The torque comes from the magnetic attraction of the coil and the friction between the steel and the armature and the steel of the clutch rotor. For many industrial clutches, friction material is used between the poles. The material is mainly used to help decrease the wear rate, but different types of materials can be also used to change the coefficient of the friction torque from specific applications. For example, if the clutch is required to have an extended time to speed or slip time, a low coefficient friction material can be used. If the clutch is required to have a slightly higher torque, mostly for a low RPM applications, a high coefficient friction material can be used. In a clutch, the electromagnetic lines of flux have to pass into the rotor, and in turns attraction and pulls the armature to contact with it. Complete clutch engagement. Most industries clutches used what is called a single flex, two-pole design. Mobile clutch of other specialties. Electromagnetic clutch can be used to double or triple flex rotor. The double or triple flex refers to the number of north or south flex paths in the rotor and the armature. Let's see how does it works. The clutch has four main parts: field, rotor, armature and the hub. When the voltage is applied to the stationary magnetic field, generates the line of flux that passes into the rotor. The rotor is normally connected to the part that is always moving in the machine. The flux, the magnetic attractions, pulls the armature in contact with the rotor. The armature is connected to the complete that requires the acceleration. As the armature and the output starts to accelerate, slipping between the rotor phase and the armature phase continues until the input and the output speed is the same. The actual time for this is quite short, between 1 by 200 times of second and 1 second. Disengagement is very simple. Once the field starts to degrade, flux falls rapidly and the armature separates. One or more springs holds the armature away from the rotor and at the air gap. Let's see the basic operations of electromagnetic clutch. The clutch has four main parts: the field, rotor, armature and the hub. When the voltage is applied to the stationary magnetic field, generates the line of flux that passes into the rotor. The rotor is normally connected to the part that is always moving in the machine. The flux pulls the armature in contact with the rotor. The armature is connected to the component that requires the acceleration. As the armature and the output starts to accelerate, slipping between the rotor phase and the armature phase continues until the input and the output speed is same. Actual time, this is a quite short, between 1 second. Disengagement is very simple. Once the field starts to degrade, flux falls rapidly and the armature separates. One or more springs hold the armature away from the rotor at the air gap. Voltage or current and the magnetic field. If a piece of a copper wire was wound around the nail and connected to the battery, it would create an electromagnet. The magnetic field that is generated in the wire from the current is known as the right hand thumb rule. The strength of the magnetic field can be changed by changing both wire size and the amount of wire turns. The EM clutch or similar, they use the copper wire coil to create a magnetic field. The field of EM clutch can be made to operate at almost any DC voltage, and the torque produced by the clutch or brake will be the same as long as the correct operation voltage and the current is used with the correct clutch. If a 90 volts clutch, a 48 volt clutch and a 24 volt clutch are being powered with the required voltage and current, all would produce the same amount of torque. However, if the 90 volt clutch had 48 volt applied to it, it would get about half of the correct torque output of the clutch. This is because voltage or current is almost linear to the torque in DC electromagnetic clutch. A constant power supply is ideal if accurate or maximum torque is required for a clutch. If a non-regulated power supply is used, the magnetic flux will degrade and the resistance of the coil goes up. Basically, the hotter the coil gets, the lower the torque will be. by about the average of 8% for every 20 degrees Celsius. If the temperature is fairly constant but there may not be enough service factor in your design for minor temperature fluctuation, oversizing the clutch would compensate for the minor flex. This will be allow used a refract power supply, which is a far less expected for a current supply. Based on V is equal to I into R, as resistance increases, available current falls and increase in resistance often result for a rising temperature as a coil heats up. According to Rf is equal to Ra into 1 plus ACU is equal to Tf into Ti, where Rf is equal to final resistance, Ra is equal to initial resistance. Wire temperature coefficient of the resistance is 0.0039 degrees Celsius. Last and final conclusion. Having designed and constructed a circuit, it was felt that it has met all the given specification, although there were still a number of improvements that could have been made. These improvements have been covered briefly in the discussion section, and given more time, they could have been implemented in the circuit. As already mentioned, the only specification not met were that on startup, the machine could rotate for 3 seconds in one direction before braking and reverse. Using the clutch method mentioned in the discussion could solve this, but the design briefly given did not explain to the cover the drum, so has not been included in the final design. During the course of the project, a number of other points became evident which greatly easy the process of the design. An electronic circuit simulates using a computer package such as PS5 saves the considerable amount of the time by allowing the circuit to be easily laid out and tested. Any changes required can be made easily without distributing the rest of the circuit. Another advantages of PS5 is the ability to produce graphs of the output from the circuit, which can be scaled, formatted and printed as required. To do this for the actual circuit required very specialized and the expensive equipment. In conclusion, the group felt that all objectives and being met, and that is a final circuit was successfully fulfilled its role. The number of improvement lessons were learned about the problems involved in designs a circuit to meet a real world need. A way for upcoming these problems were found. Thank you.